Okay, so this learning objective is a direct continuation of the last learning objective, but it actually doesn't use the last learning objective specifically, because we're just talking about more identities, but in this case, we're just talking about a different identity. So we're going to add on the number of kind of different things we have. Again, the nice thing with these identities is I'm not going to require you to memorize them. So now we have these things called double angle formulas, double angle identities. And it's just what happens if I have twice of some given angle in the parentheses. So these formulas work out a little bit nicer than the previous ones because just multiplying an angle by 2 is a little bit simpler, just kind of adding two random angles together. Again, you don't need to have these memorized that sine of 2 theta is exactly equal to 2 sine of theta times cosine theta. But you should know that an identity for this does exist, so when it comes up, you can go find it in the correct place. And again, on exams and stuff, you're going to have access to these formulas because I don't expect you to memorize 15 trig identities or anything like that. All right, that's kind of brain power you don't need to waste. All right, but in this kind of learning objective, we're going to figure out how to use these identities. All right, so you can see there's one for sine. All right, it's always the exact same identity. Cosine is a little bit weirder because cosine, its formula ends up having these cosine squareds and sine squareds in it. And because of the identity that looks like this, which I actually mentioned in the last video, I can replace sine squared or cosine squared with some other things. All right, so you actually get these alternate formulas for the cosine one that you don't get for the sine one. That's all coming from this kind of comparison with the squareds and stuff. You see there's a minus sign here, not a plus sign. That's why it's not just always equal to 1. But nonetheless, I can kind of do some replacements and get some other formulas. All right, so again, have these things kind of in a handy place where you can reference them for whenever you need to use them. All right, so our first example, all right, find the value of cosine of 2 theta if sine of theta equals 3 over 7. All right, whenever you're doing a problem where you're finding cosine of 2 theta, you actually have options. There's 3 different options we had on that last slide. And generally, one of them is going to be kind of the least amount of steps. You can always end up using any of them, but they might be more steps. All right, for instance, we have the formula that looked like this. But to use this formula, I would have to figure out the cosine, right? I don't know the cosine of theta from this original problem. All right, so that one's actually going to take longer than if I use the second formula that was listed. That look like that, because that one only uses sine. All right, so the cosine of 2 theta that we're looking at, I'm going to use this second formula. And I'm also going to remember this notation here is just a shorthand for sine of theta, that whole thing squared. All right, so that putting that little 2 there just kind of saves me one set of parentheses. So when I put this in, it's going to look like this. All right, instead of sine of theta, I'm going to put what it's equal to, 3 over 7. And that's squared. All right, so that's how I can plug that into the equation, remembering kind of where that squared goes. And then it's just order of operations, remembering that exponents happen first. All right, then multiplication is going to happen. And then the subtraction, but to do the subtraction, I have to get a common denominator. And then I can finish the problem. That's going to become 31 over 49. And that would be how I use this formula to figure out cosine of 2 theta. So again, I have no idea what the angle is, but I know twice that angle's cosine is 31 over 49. All right, so keep this in mind for this next example. You're still trying to figure out cosine of 2 theta, but you want to use, or you have cosine. All right, so think about how you can use your formulas effectively, all right, and try to solve this problem. And here's the solution I came up with. So in this case, I use that third identity on that slide where I only have to use cosine because that's what I'm given. I plug in the 4 over 5, square it, multiply by 2, subtract 1, and you get your final answer down here of 7 over 25. All right, so the other thing we could do, just like in the kind of last learning objective, is actually doing it for specific angles. All right, so find the value of cosine of 120 degrees using the double angle identities. Well, if we're using double angle, we need to figure out that 120 is actually twice of the 60-degree angle. Because if I want to use the double angles, I need that extra 2. And then again, I can use any of the 3 ones here. In this case, it doesn't really make a difference because we're not given the original sine or cosine, so you can kind of pick your favorite one. And let's say I just picked the sine one. All right, there's nothing specific about why I'm picking the sine one. All right, but that goes there. And again, when I have 2 theta, just theta's here, so just the 60 degrees is going to go in that parentheses, because when I have my formula, the 2 is on the front, but it's not on the back. All right, things are a little bit different here because sine of 60 I can do using my unit circle. I know that's the square of 3 over 2. And then I can simplify the same way. So first thing, squaring things. When you square a square root, it just goes away. And then I can multiply by 2. Then I can get a common denominator. Then I can subtract. And finally, I can simplify. And this one simplifies really nicely down to just -1/2. And we could actually do this without doing the double angle formula by just knowing that cosine of 120 is related to cosine of 60 and get that -1/2. This uses that new formula and also shows how when I get the 2 times an angle, just that angle is going to go in that parentheses in the formula. All right, so really similar to when we were doing sum and difference, we just have a 2 in that thing, all right, in the parentheses, but we still just follow the formula, simplify correctly, and get our answer. All right, so for your one, find the value of sine of 60 using the double angle identities. And here's the solution. Again, you could actually do this problem without doing the double angle identity, but just for practice, all right, sine of 60 is the square root of 3 over 2. But we could also do it by saying 60 is twice the 30-degree angle. Here we just have that one formula for the sine, so that 30 is going to go in those 2 places in the formula. We can use our unit circle. Sine of 30 is 1/2. Cosine of 30 is the square root of 3 over 2. And that 2 at the front and the 1/2 cancel, and we get that final answer there. All right, so to finish up, just a multiple choice question about cosine of 2 theta. All right, if you're trying to find something that has cosine of 2 theta in it, which of these formulas could you not use? All right, so only one of those would not be applicable if you were doing cosine of 2 theta. All right, so answer that multiple choice question, and again, move on to the practice and start utilizing these new identities.